everyone, my name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject Microcontroller and Embedded Systems Design Hemming Code KEC 061, what we have covered, we have completed our unit number 1st, 2nd, 3rd and 4th. So, right now in these lectures, in previous lecture we have started with the unit number 5. Unit number is basically a simulation of the IoT application, simulation of the circuits. So, in this lecture we will talking about the introduction to the Mbed platform, and here we will see the functionalities and component of the Mbed OS. OS means operating systems. So, these are the table of contents that we will cover in this lecture. So, under this topic, that is describe the Mbed platform and its functionalities, we will discuss the introduction to Mbed, what is Mbed basically, what is ID, integrated development environment. We will see some examples of Mbed hardware platform in this lecture. After that, we will see the these are the functionalities basically. After that, we will see what are the different components of the Mbed OS. So, the components of Mbed OS is Mbed RTOS. RTOS means real time operating system. We have a threads, Mutex, Semaphores. So, here this is the we are talking about the functionalities. Here we are talking about the components of the Mbed. Okay. So, we will discuss one by one. So, first topic is Mbed platform and its functionalities. We will look the what are the functionalities of the Mbed. So, first question arises, what is Mbed? So, basically Mbed is a platform used for easy prototyping and development of applications and systems based on ARM Cortex-M based microcontrollers. So, what is happening out there? Mbed is basically a open source platform. You can use open source, there are open source libraries available. So, in traditionally what we have done, you can use it is like a Tinkercad. We have I have told in the previous lectures. So, what is you cannot use hardware like breadboards, large number of CRO function generators, all these are available in Mbed. So, basically this is a open, you only need a web browser, it is a open available software platform. So, it is basically used for easy prototyping. You can, if you are for example, if you are going for any IoT application, for example, you are going for home automation, you have large number of circuits. So, before designing the hardware, before designing the IoT application, you can create prototype in your Mbed platform. So, after creating of the prototype, you can run the circuit. Okay. So, before designing actual hardware, you can check its functionalities in Mbed platform. So, Mbed platform is basically provide a visualization of the our network. Okay. So, it is used for easy prototyping and development of application. Any IoT application can be developed in Mbed platform. So, and system based on, so basically it is utilizing the ARM Cortex-M based microcontroller. It is basically two things have here, we will discuss in further slides. It has a SDK and HDK. So, SDK means software development kit and HDK means H means hardware development kit. So, in hardware development kit basically utilizing the ARM Cortex-M based microcontrollers. Okay. So, Mbed platform has own hardware, with these types of development boards are compatible with the Mbed type of programming language. So, basically Mbed platform provides open libraries, it has a open software libraries, anyone can use it. Okay. It has a open hardware design, it has a open hardware design, anyone can utilize the hardware or designs. So, for any hardware it is compatible. Okay. Open hardware designs are possible, there are a lot of microcontroller boards are there, you can use that, and the tools available is online. Okay. Open online tools for professional rapid prototyping. You can develop any prototype, any hardware circuits, and for that we have a open online tools available. So, of products based on ARM based microcontrollers. So, here you can see 3 picks: Mbed SDK, Mbed SDK and Mbed compiler. So, in the previous lecture, in the previous slide we have talked we have already discussed that Basically, there are two things in Mbed, SDK and HDK. Okay, software development kit and a hardware development kit. So basically, the meaning of the software development kit means that we have a interface to write the programs. Okay, so for writing the programs in Mbed platform, you have open source libraries, open source codes. Okay, this is one of the interfacing pick. And we have a Mbed SDK as well. SDK means hardware development kit. So hardware development kit, along with the programming, we can we can create any type of circuits and we can do its simulation. Okay, and after both the software and the SDK, the end product is can be completed by using the compiler. We can use the Mbed compiler to compile the codes which we have already generated. We can compile any program, and we can debug it, and we can implement in the final IoT applications. Okay. So we will look into the more about the introduction to Mbed. So Mbed platform basically includes, first one is the standard based C++ software development kit. So basically it has a C++ software development kit. Okay, C software these type of languages are already available in our 8051 microcontrollers. So it is compatible, Mbed is compatible with the C or C++ development kit. It has all types of libraries, codes available according to the C language. It has also have a here we are talking about the software. We are in this point we are talking about the hardware. So it is also has a hardware development kit. In a hardware development kit, there is a microcontroller, and this microcontroller is basically ARM based microcontroller. Okay, and it supported development boards. It for any development board, it is compatible. Mbed is compatible. So it has a integrated development environment. In this it provides an integrated development environment. For example, in Arduino microcontrollers, it has own integrated development environment. You can program, you can write the codes in that integrated development environments. So it including an online compiler. It has an online compiler available in Mbed. There is a online compiler available, and online developer collaboration tools. Collaboration tool means that you can use another tools. If for example, I am sitting in the UP, and someone in the Kerala writing codes for creating new codes, writing codes. So you can at the remote location at here we can use the codes created by the another location. Okay. So all these codes are available online, so you can access from the internet. Okay. So Mbed is a platform and operating system for interconnected devices based upon the 32-bit ARM, Cortex-M microcontrollers. In the previous lectures, we have discussed about the ARM, Cortex-M microcontrollers. Here you can see that M0, M0 plus, M2, M3, lot of microcontrollers were available. Okay. So such devices are also known as Internet of Things devices. The project is collaboratively developed by ARM and its technologies partners. So as a final year students, especially if you are creating develop any IoT based project, you can simulate it, you can virtually analyze it in your Mbed platform. Okay. You can just you have need some laptop or desktop, you need a web browser, it should have an internet connection. You can go into the you can in Google you can type Mbed. Okay. So there were Mbed platform available. On that platform you can write the language, you can debug it, you can in your development board you can burn that program. Okay. So it provides the IDE, integrated development environment. So Mbed IDE provides an Mbed online compiler and tool chain for rapid application development. For any application you can develop in Mbed platform. So for that online compilers are there in the Mbed, online open tools are available, you can use that. So the advantage of Mbed is that it has a lightweight tools. The tools are very easy to use, lightweight tools, not much complicated, anyone can use them. Okay. It has an online web based IDE. Okay. Your project can be accessed from anywhere. For example, if you are at college and go your home at a remote location 200 kilometers away, and you have done something at your home, and you forgot to carry laptop at your college. So if you have done something about your project at your home, you cannot access it at your without laptop. You cannot access at your hostel colleges, in a hostel in your college or somewhere you are sitting at the PG. So Mbed provides the alternative to that. You only need the online platform, online connectivity. You only need the internet connection. So all the libraries you can save in your ID, you can save your Mbed platform. So only you need internet connectivity. It is not like another languages you can install heavy software, and you can write you save file in your laptop. Okay, so from anywhere you can access the Mbed platform. Okay, so it has a online web based ID, no installation needed, only web browser is needed, only you need Chrome, only you need Mozilla, Firefox, etc. No installation of the heavy hardware needed, like another software MATLAB, it needs gigahertz of bytes of memory to install. Okay, it is free of charge, no cost is done by the companies. Our mindset is that if someone is charging, we cannot we avoid that particular thing. So it is free of charge. All the library tools are freely available in the internet. It has a convenient code sharing. Anyone, the code we are using here is very convenient to use. Everyone can import code libraries from others. Okay, everyone can import or codes libraries. It is openly available at anywhere. You can use the code developed by the another user. Okay, everyone can export codes or library to the community. For example, someone at Kerala or Bangalore creates codes for Mbed. It puts that code into the Mbed libraries in open platform, and anyone in the globally, anyone in the at any country, any place can use that codes or libraries created by another person. Okay, that is the advantage, main advantage of the Mbed. So anyone can import codes, anyone can export codes by using the Mbed platform. So this is images, actual images I have taken from the Mbed. So basically this is the interfacing of the Mbed compiler. So it has various options available: new, import, save all, compile, commit, revisions, like another API we are using it. It has some libraries available: program workspace, AD example, default. Many tools are available here: USB mouse, USB keyboard, web sockets available, Wi-Fi terminals are available. It has we can use C or C++ language to write our programs. For that we have some lines: include mbed.h. We have a so you can write in Mbed platform, you can use C++ language to write your program, and after writing the programs you can burn that program. Debugging is also available there. So after debugging or writing or debugging the program, you can burn your program into the development boards in any microcontrollers. Okay, so this is the pic of the I am taken from the net: ARM Mbed NXE LPC low power unit 11UT4 development board. There are many development boards are available. You can only you need to only web browser, internet connection. You will go to the Mbed platform, write program there, debug that program, and you can in a development board you can burn the program. Okay, so this is basically ID, open integrated development environment. Okay, so another pic, this is ARM Mbed OS simulator there. It has a blink like on Arduino you can use a blink app to write your languages. It has all the tools, open tools available to write a program, include mbed.h libraries are available. So any IoT application can be its prototype can be done in Mbed platform. There are a lot of libraries are available. It is easy to understand, easy to use. Okay, so this is basically a program. You can see the blink LED program. It has a 500 millisecond of delay, and you can write program in the Mbed OS simulator, debug it, and deploy, and in hardware development kit you can run the program. So this is the output. So you can check the output, you can debug it, all the functions are available in the Mbed platform. So examples of Mbed hardware platforms are, Mbed hardware platforms are already manufactured development boards. Okay. So development boards are based on the Mbed hardware development kit. So it has a hardware development kit. Hardware development kit under there are lot of development boards are available, like Mbed LPC 1768, Mbed LPC 11U224, Freescale KL25Z, Mbed NXP LPC 812 Max, EA LPC 4088, DIP Cortex M0, all are available in, you can see in internet, you can see lot of development boards of Mbed, DIP Cortex M3, Bluebird, board LPC 11U24, Wi-Fi, DIP Cortex are there, C, do you know, architecture are there, LPC 1114 FN28 are available, lot of development boards are available. You can use any development board, you can write your program through Mbed in any development board. The program you are writing in the Mbed is compatible with any development board. So it provides quick way to get started with the Mbed platform. You can write very quickly into any development board. Okay. It is specifically optimized for flexible rapid prototyping. Any prototype can be, you can develop. Okay. And it is available from distributors worldwide. Examples are, so worldwide there are a lot of distributors are available. We have already seen that provide that development board to the users. Okay. So after that we will talking about the components of the Mbed OS. So in the previous slide we have seen the functionalities of the Mbed. What is the functional of the functionalities, different functionalities of the Mbed. So from this slide we will talking about the various components of the Mbed operating system. So the main components to which Mbed relies is RTOS, real time operating system. It works on the real time operating system. It is not works on the general purpose operating system. So all our embedded devices, IoT based devices works on the real time operating system. They relies on the real time. For example, ATM machines are works on the RTOS. They are RTOS based system. You are just inside your card, and at the same time, within 1 or few second delay, you can get your money. Okay, the cash will dispense. So they are working on the real time. If they are general purpose, they are not relying on the real time applications. You can the cash will dispense after more time. Okay. So basically it has the API application protocol interface, peripheral interface. It relies on the RTOS. Okay. So it is basically provides easy to use API. Anyone can use the API. Okay. You do not need to learn the very complex programming. It is very easy to use. Anyone can use the API of the Mbed for programming Mbed enabled devices. It is basically based upon the Keel RTX RTOS. You already know that there are some Keel compilers to write microcontroller program, debug them. So it is based upon the Keel RTX RTOS kernel implementation. It uses the CMSIS. After 1 or 2 lectures we will discuss the CMSIS Cortex microcontroller. Okay. System we will learn in our upcoming lectures. Cortex microcontrollers. Basically Mbeds are based upon the ARM Cortex microcontrollers. Okay. So it also has a CMSIS RTOS API open standards. Okay. So CMSIS RTOS API basically has a common API for real time operating system. It works on the, it has all the API is very common. It is a common API means that everyone can use for every applications the API will run. Okay. It is not like that for few particular applications you can only run the API. For every IoT based application you can run the your RTOS API. Okay. It is common to all. So foundation of the official Mbed RTOS. Okay. So Mbed, there are all the libraries, there are lot of codes are available, lot of libraries are available, all are openly accessed by the user, and it is very easy to use. Okay. there are some guidelines also available to use it. So, we will look into the more depth of the Mbed RTOS. It provides a standardized programming interface, anyone can use it. It is easily portable to many RTOS. Okay, you can, the program you that is written into the Mbed RTOS basically can run on the any IoT based application. It enables software templates. It has a itself templates available. It has a middleware libraries, lot of, it has a open source library available and other components that can work across various supported RTOS system. So basically Mbed RTOS has its own libraries, own codes available, and the following slides, in the upcoming slides we will see some more Mbed RTOS API like threads, mutexes and semaphores. What is the meaning of thread? Thread is basically a like a task, the task of the any embedded system, any IoT based system, any application. For example, the task of the ATM machine is like in the waiting state, in the running state, in the ready state, ready to run. Okay, these are the tasks. Mutexes means if there is more than one thread, how to manage that thread by using the mutex. So, mutex is basically used to control the threads to for example, we have more than one thread. So, the resource utilization, the shared resources are how much shared resources are given to which thread, all are managing through the mutexes. And after that we have a semaphores. We will look into further slides. Semaphores is basically to manage the resource shared memory, okay, resource utilization. For that we will use semaphores. So, we will look into one by one. First one is the threads. So, threads is basically a task. Okay. So, in Mbed RTOSI, a task can sometimes be referred to as a thread in multitasking system. Task is same as threads. So, what is the meaning of task? For example, in any IoT based applications, we have some tasks. Task means basically a job of the microcontroller, job of the IoT applications. Like it is, it has some states like ready, waiting, running, inactive. For example, in your we can say that ignition system, if you are going for a drive, what you will do, your car is in the idle state. When you ignite it, it will go into the ready state. You will run your vehicle, it go into the running state. You can stop your vehicle, it go into the stop state, start state. There are lot of states are available, that are the task of the microcontroller. Task means that are the threads available. Threads also, some people also say that threads is like a interrupt in the microcontrollers. It can happen at any time. Okay. So, managing of the threads will be through the mutex. So, the threads available are running. Running basically a thread that is currently running is in the running state. Only one thread at a time can be in the state. So, in a running state only one thread is possible. So, running means basically we are going to run the application. So, this is the running state. Okay. So, only one thread is available. So, after that we have a ready state, that is ready to run. So, threads which are ready to run in the ready state. So, it didn't have a one thread, it has a more than one thread. So, once the running thread has terminated or waiting, once the running thread is terminated, we will go into the we will next the state is available is ready. Okay. So, if we are terminated this running state, waiting state, then it is going to the ready state, that is ready to run the application. So, also it has some priorities. For example, if more than one task occur, the system will do the task according to the priorities of the threads. It is like already we have said that it is like interrupts. For example, in any microcontroller more than one interrupt occurs, the microcontroller will access service the that interrupt according to the priority. Highest priority interrupt will be given service first by the microcontroller. Okay. So, on the same way threads are working. Okay. This is so more available, more task available, waiting, inactive. So, waiting state means threads are in the waiting for an event to occur. Okay. For example, in the ignition of the car, the waiting state should be to run the vehicle, to ignite the vehicle, okay, ignite and accelerate the vehicle. Inactive state means doing nothing, we in the idle state, okay. Threads that are not created or terminated are in the inactive state. These threads typically consume no system resources. Inactive means we are doing nothing, we are not using any system resources. Inactive means we have terminated the process. Here you can see that from the ready state we have terminated the process, we have from the waiting state we have terminated the process. So a thread is a single sequential flow execution of task of a process. So it is also known as thread of execution or thread of control. So there is a way of thread execution inside the process. So threads means we are talking about the task of any IoT based application. After that we have a mutex. Mutex means mutual exclusion object. Basically to managing the thread, if in any system more than one thread occur, it can be managing through mutual exclusion unit. So ensure no two threads are near a critical section. The working of mutex is that it ensure the effective utilization of the threads, okay. So in RTOS the mutex is used to synchronize the execution of threads. All the threads that is in any RTOS based application are synchronized through the mutex, and it can protect access to shared resources such as shared memory image. So here you can see that in a mutex system the shared resources can be effectively managed through the many threads through the mutex, okay. After that we have a Semaphores. Semaphores, it is basically a variable of abstract data type used to manage and protect access to shared resources. So basically the difference between Mutex and Semaphores is that both are used for managing the resources, but Mutex is used to managing the threads and Semaphore is used to managing the shared resources. So Semaphores only manage that shared resources, you can see in this diagram, and the threads are managing through the mutex, okay. So unlike mutexes does not have the concept of an owner, like in mutex it has a owner, it can access the threads. So unlike mutexes, for example, with a semaphore, access to a group of identical peripherals can be managed. So many large number of threads can be managed to mutex, and semaphore, how much shared resources are given to any thread, it is managing through semaphores. So semaphores, basically it has an integer value s variable like here, and it has a two atomic operations, wait and signal, that are used for process. So in the wait state we are going the wait operation. So if s is negative or 0, if s is negative or 0, okay, so we will use the in the wait state. So if s is negative or 0, no operation is performed. So here we are writing the code for semaphores wait s while s is smaller than equals to 0, do not operation. So s is equals to s minus 1, it is works on the wait state. So after that we have a signal stage. In signal stage s has a positive operation, s is equals to s plus 1. The advantage of semaphores is that no resource wastage is there. Effectively the source is managed through the by the threads. It allow only one process to occur, no more than one process are occurring there. It is machine independent, it has own codes we can write for any particular application. The disadvantage of semaphores is that it is very somewhat complicated to, and it is impractical, complicated, no one new user can use it, you have to follow some guidelines, impractical to use. It has a priority inversion. Sometimes it happened that priority inversion means that, for example, there are P1, P2, P3, P4. So lowest priority process can occur by the system. So this is priority inversion. Low priority task will given priority first, okay. So thank you everyone for your patience. I hope you have enjoyed my lecture. Thank you all.